Okay. Forget everything you've learned about work problems. Forget about the fractions. Forget about this. Forget about tables. Whatever. I just want you to remember work equals rate times time. Okay, so we're going straight to the hardest problem, which is Ron can finish cleaning the house in 5 hours. After working for 1 hour, Vic joined her. If they finished cleaning the house in 1.5 more hours, how long can Vic finish the work alone? Take note of the 1.5 more hours. Okay, so stated there that Ron can finish cleaning the house in 5 hours. So we can transform it into this equation. It says that in 5 hours, Ron can complete a job, which is 100%. So we could simplify. I use this because of this. Okay, 100% per 5 hours. We can simplify that in 20% per hour, which is our Ron, right? We could easily visualize what this means. It means that in 1 hour, 20% of the whole task is completed. Okay? The conventional ones, which is converting this 1/5, the fractions, it is hard to imagine that 1/5 is the rate of Ron. So I'm not going to use this. I'm going straight to the percent, but they're the same, okay? They're the same. Okay, we're going back to the problem. After working for 1 hour, Vic joined her. So I made the timeline over here, which is the time and the percentage of completion. After 1 hour, somewhere here, Ron worked for 1 hour, right? So that means 20% of the job is completed, right? Because Ron can finish a job 20% per hour. So that means in 1 hour, 20% of the job is complete. The goal is to land on the 100%. How are we going to do that? Since 20% of the job has already been completed, there's an 80% more. There's an 80% more work to be done. So, since this is the only equation we know, we could write 80% equals rate times time. So what are we going to do next? It says there that after working for 1 hour, they have finished. Vic helped her, and complete the job in 1.5 more hours. So that means after Ron doing the 1 hour job, 1.5 hours more, somewhere here, 1.5 hours more, they have finished the job. That means at this point, they have already completed 100% all in all. So this is 1.5 hours, so this must be the graph. So just so you could visualize the problem. So what are we going to do next? So the 80% was worked by Ron and Vic at the same time, which is 1.5 more hours. In 1.5 hours, they have completed 80%. Okay? So 80% equals their rate times 1.5 hours. Okay? So the rates must be combined because they are helping together. So are we going to do 1/20 plus 1/r or 20 plus r, which might confuse you? So this is the best thing you should, just in case you forget. Here's the thing. Here's the problem, them working together. The first option is to put this or this, right? So if you put this, and for example, I just put some rate 21, I made them fractions. The time would be a lot larger if you do this, instead of actually doing this. It means that, I'm just saying that logically, if two people help together, the time it takes to work to complete the job must be a lot smaller. So that means they're not fractioned. Do not do anything about like this. Just add them together. Just add them together. So 20. I'm gonna erase this because there's not much space. So 80% equals the rate of Roan 20% per hour plus rate of Vic percent per hour times 1.5 hours, because they have completed an 80% in 1.5 hours. And I've already solved this. This is 33.33% per hour. Okay? So that's how Vic can work. So going back to the problem, how long can Vic finish the work alone? So going back to the original equation, the work equals rate times time. Completing it alone, completing 100%, we have this already from the 33.33%. We could get the time it takes for Vic to work and complete the job, just like how Ron did in the first sentence. We could plug and chug, plug this one here, and we could solve that TV equals 3 hours.